Welcome to another episode of Playing with Junk. This time we have this device here, which I first didn't know what it is, but when I saw the old Powermac G3 here, I thought that could be interesting just because of the computer itself, and maybe it's something interesting too. Well, let's have a look. Alone from the look of it, it must be something medical, and here is the user guide. It's an Atomlab 950 medical spectrometer from Biodex Medical. The medical spectrometer is more or less this tube here, together with a small box that is under the computer table here, and it analyzes gamma radiation that comes from patients that have been treated with some nuclear medicine stuff, for example cancer treatment and all kind of these things. And it's not only to measure how much radiation someone got, it also can differentiate the kind of radiation. So at the end it's a spectrometer, and you can say what radioactive substance is active here. Let's turn this thing on, and then we can see on the screen what it can do. So let's first look what it is. So I already said that's the detector tube. It moves a little bit hard, not much to see inside. There is a scintillator material in the front. That means if it gets hit by radioactive radiation, it emits light, which is then amplified by a photodetector tube, which is in the back here. We will see that later. And the amount of light and the strength of the pulses is characteristical for the radioactive isotopes. And this box here checks and measures everything. It's not a big box, just like that. It has a high voltage power supply inside. I think the amplifier tube runs on about 1 kilovolt, something about that. And there is a counter that counts all digital analog converter, and the counter that counts all the impulses, the strengths and the intensity. And there is then a serial interface that goes up to the Mac, and that's it. Then we have a power transformer here. That's an insulation and step-down transformer, because all the gear here is made for 215 volt. We have for 115 volt we have 230 here. And we have a desk writer 600, which is about the same age as the Powermac. We will see if that is still writing. I have my doubts, because I think I had one of these in the early days. It was probably my first printer, and I remember if you didn't use it for 1 week, then the ink was already dried up and you had to clean the cartridge and everything. Okay, then Powermac G3 with a CD-ROM, a zip drive, which was standard in the days, and a floppy drive. And I think the screen is a little bit more modern than the rest, so I think this unit originally came with a CRT screen. You can also see the footprint here was a different one. Then that's the back side. We have a video card output, we have TV out, we have some kind of DFP. I don't think you can see that against the light. Okay, maybe like that. Then we have a SCSI card, which is not used on this system. Then we have an audio video input output card, which is also not used here. That's the original video port from the Mac with an adapter. You can also hook a VGA monitor to that. It's not used. We have Ethernet built in. That was quite a sensation in those times. There is the switch for 150 to 130 volt, and I set it to 115. That's the Apple desktop bus. You can see the logo. That's where keyboard and mouse go in. They share the same cable because it is a bus. We have serial printer and a serial modem. That's where our box below is connected, and the printer cable goes, of course, to the printer through the hole here. Well, I checked all the voltages, and let's plug it in and see if it's still working. It seems printer has power, that box has power, power strip. There's also a light that comes on. Monitor is still dark because it's plugged into the Macintosh. Now I show you something that I really miss on the modern Macintosh. It's the power button on the keyboard. Bling! On all the modern Macintosh you have to reach behind the machine because they hidden the power button somewhere. I don't know why, because it also works like this. Mac OS 9.2. That's shortly before 10, or OS X, as some people call it. Yeah, it seems to work. Okay, there's a message. Yeah, it complains that the clock is not set. Possibly the battery is empty. Well, let's try to set the date. So that's the mouse here. It's a trackball. You can see that. It doesn't work perfectly, so maybe we first have to clean it. It goes well to this side, but it doesn't go so well to the other side. So I think I will fix that first, because that's a little bit annoying. That trackball device works like a mouse with a ball, but upside down. But maybe you're too young to know that mice have had balls one time. You could take them out to clean everything that was necessary. You can see the dirt here on the rollers. And it's the same principle here. You can easily lift off the ball, and you can see the rollers here. There is one for the vertical movement and one for the horizontal movement, and then there is a third one that simply makes the ball roll easily. And you can see they are dirty, and I just want to clean them. So what you need is a little bit of alcohol and a cotton swab here. Then we clean that, and you may notice these wheels here are made of metal. That's quite unusual. Normally they are plastic or rubber or something, and yeah, they are pretty dirty. So we have to go a few times around. Yeah, that's really thick dirt. Yeah, I think I need a new one. So if they are too dirty, you probably have to take everything apart. But here in this case, I think it's working like that. Okay, you get the picture. I will do the rest without you. Okay, it seems cleaning did help. It runs wonderful from one side to the other, up and down. What is now? Oh, the program has started. I don't want to do that at the moment. Exit to Macintosh. I just want to set up the clock. That's the old version where you have to keep the mouse button pressed. That's a little bit difficult here. Date and clock. Yeah, 1956, that is certainly not true. 2018, I hope it will not explode right now. It's the 21st. And it's, I have to guess, probably 1800, somewhere about that. Okay, close that. Time has changed and we start the application, the A950 app. Probe. High voltage adjustment is over 1 year. Yes, it stood in the basement for probably more than 1 year. Okay. Verification, okay. Let's try this one. Okay, that's a template patient analyze. Okay, we didn't set up. Okay. We can print a report. What did I want? Administration, maybe. We have to calibrate this thing because it has not been calibrated. Well, the last time was 2014. Calibrate. Places cesium 137 source about 9 inches from the end of the probe. Yes, of course I do have a cesium 137 probe. If one of you has one, let me know. I don't have one. So what I wanted to show you is the manual mode, because here we can select all kind of radioactive isotopes. Let me zoom in a little bit. Gold, barium, cobalt, chromium, where is it? Here. Cesium, iron, gallium, mercury, iodine, natrium, palladium, strontium, technetium, all the nasty stuff. Okay, we could choose that. isotope name. Let's see if that changed. Calibrate. No, it still needs a cesium probe, so that's used for calibration. Let's see what the printer does. It's blinking. It has a little bit problem to pull in the paper. Maybe I have to help it a little bit. Yes. So what's happening? It makes noises. Sounds like printer calibration or cleaning. Okay, I know that page. I started the print shop again. Okay, not yet. I have to press the OK button. So if you help it a little bit, it can pull the paper in, and it sounds like printing. Yeah, there are a few dots. That's more than I expected. Maybe we can fix that. Okay, let's clean the cartridge and we will see. It's very easy here. You only have to open the cover and the cartridge will move into this position where you can get it. Cartridge 29, so it's only a black and white printer. We only have black ink, nothing else. So let's try the oldest trick. We add a little bit of water and start making the cartridge a little bit wet. There is the print head. That's where the tiny channels are that get blocked by the ink when it dries. So I think you can see it here now. That ink is actually coming from this cartridge. You see there are two stripes for two rows of print heads. So yeah, you can see that here. Two rows for the two rows of holes where the ink shoots out. So probably that will work again. Okay, printer doesn't want to print, so I think the cartridge is really dried up. But I connected the Ethernet here because I wanted to see what the www browser looks like. And I noticed that if I connect a 10 megabit Ethernet directly to a 1 gigabit switch, it doesn't work because the 1 gigabit switch can only go down to 100 megabit. So I needed an older switch here. That's a 1000 switch, which I use to convert. So this cable here has full 100 megabit. The other from the Mac has only 10 megabit, and that seems to work. So let's start the www browser. What is it? Internet Explorer. And is that everything? New window, okay. Okay, let's see. www.google.ch. We are in Switzerland. Yeah, Google. And it's not even slow. Let me search something. Any 4-letter word. Yes, seems to work. It's only HTTP, not HTTPS, because I think there is a problem with the secure protocol. Let me try that. YouTube. Yes. No. It can't do a secure connection. Maybe it doesn't have the right decryption plugin. Not enough bits, probably. And YouTube doesn't work without HTTPS. Maybe something else. Nope. So all the secure HTTPS websites don't work. No, everything is secure today, so we probably need an update. Do we have another browser? Maybe here? No. QuickTime? No. Internet? No. Explorer? No, that's the same. Okay, it works, but it doesn't work. So, let's have a look at the tube. That's something you're all waiting for. Let me shut down the system and then we will take that thing apart. Well, I noticed that the joints here are really going heavy, so I try to lubricate them a bit. Maybe that helps. Yeah, a little bit. Okay, but that's not the most important. There are two screws, one on this side and one on the other side, and of course I have unplugged the mains connection, so there is no high voltage around here, I hope at least. So we can take that out. Okay. Doesn't look very exciting. I always wondered why this card here is so heavy. It weighs about 300 pounds or 140 kilos. And there's only a Macintosh, a printer, a little bit of electronic box, but the entire tube here has a thick layer of lead. Yes, it's lead. You can see it here. It is soft. You can scratch it easily. Also here on the cover, on the back cover, there's a lead insert. And now the rest is, I think that's aluminium. And that's the tube, or however we operate at positive high voltage only. Okay. There, the thicker wire here, that's the high voltage supply. They use a coaxial wire. And the thinner wire is the signal output. It looks like there is some kind of socket. Maybe we can unplug that. I need 2 hands for this. Okay, let's see, there is some tape around here that should probably provide some shield and keep it from falling apart. Yeah, that's easy to unplug. Okay, seems that's a ground wire here. They simply wrapped it around, so that's probably good enough. There is a part number or a serial number, maybe. So it's the model 2M2/2 from Bicron, made in the USA. Serial number, yeah, doesn't look like much. So I can say the front here seems to be relatively massive, but here on the end it's only a thin wall. Maybe there's glass inside, maybe not. So that seems to be the image intensifier tube, or well, not an image intensifier, it's a photomultiplier, because you want to measure single photons that have to be amplified here. Yeah, also the board here looks like the connection board of a photomultiplier, because the photomultiplier has several electrodes and each one needs a little bit higher voltage than the one before, and that is easy done with these resistors that go from one electrode to the next, and so they make a voltage divider. Passive resistors, that's it. Well, I'm putting everything together because this time I really want to see how this thing works, if it still works. So I put it together carefully. Well, you may ask, why is there such a thick layer of copper inside this case? Well, it's simple, because you want to measure the radiation that comes from the front, and everything else would just disturb the measurement. And the other reason is this unit is very, very sensitive to all kind of radiation around, so you need that shielding. And another reason why this unit is so heavy is because there is the heavy lead-filled cylinder here, and here we have a lift mechanism which has counterweights inside. You can see the steel cable here going up and down. Where is it? There is it. And of course the counterweight must have the same weight as this tube assembly. There is a screw to fixate everything. Well, I think that's it for today. Maybe if I find a cesium-136 probe, then I will probably be able to calibrate this and we can do some measurements. That would be fun. Thanks for watching.